able to take your class due to some family engagements. I repeat, for each and every one of you, I will be repeating the information at the last of my class also, because last time I remember when we did not connect on 31st of December, there were one or two guys, those who were not present in the class on 30th. Then they were a little, it was a little matter of worry for them that why we are not having the class. Then I still remember when someone asked, then some other one of you answered on the WhatsApp group that today we are not having a class. So I don't want anybody to bother this time. So I repeat, tomorrow I will not be taking your class. Okay, so let us start. So I'm going to share the screen. Yeah, class, can you see the screen? Okay. So class, we left at this point, and if you recall by our yesterday's discussion, our aim is to show that this G is constant, this G, which we define like this. And I explained it to you yesterday that once we have shown that this G is constant, then so now let's start computing G dash T. So because class uh, phi is partial is having partial derivative with respect to t, and after taking partial derivative it is coming out to be, I mean, phi is continuously differentiable the way we have chosen phi. So we can apply Leibniz rule, and according to that we have this. So now let's continue further. And if you recall, and if you recall, uh, we denoted del phi by del t with the help of this psi s in this expression number 3. So yeah, so now let's continue. So class, um, consider this, consider the following function. Fs is equal to 1 upon it f of z plus t this, and s belongs to closed interval 0 to 2 pi. Class, class, then it's an easy exercise to check that f dash s means simply nothing but class the ordinary derivative of f with respect to s is a real parameter here. You can see that it will come out to be 1 upon it. I'm just doing it for you, very easy exercise, and into TEI EIS, and you further simplify it, it will be EIS f dash z plus t EIS minus z. And class, if you notice, this is nothing but this, that is what we have called as psi s. This we did yesterday, you see it here, class, it is this. Is this okay, class? So it means what, class? It means class, that is it means class, that is f is a primitive for psi. Is this okay, class? Is this okay, class?
Yes, sir.
Yes, sir.
So therefore, let's further start with. So therefore, g dash t is equal to, it was, what was g dash t? G dash t was this 0 to 2 pi psi s ds. It was this, class, psi s ds, right? And so its value will be what, class? Its value will be capital F
F
of.
at 2 pi minus
F
F
2
at
pi
0.
minus F0.
Very good. All right. Now, class, uh, let's now let's try to find out the value of f at 0. So you can see that if you put s is equal to 0, class, so you put 0, so you will put 0 here. So you will have e to the power 0 is equal to 1. So I think you can easily see that what will be f0. So I am writing that for you. So f0 will be, class, 1 upon it f of z plus t 1 minus z. Is this okay, class? And likewise you can see, class, f of 2 pi will again be the same, because, class, e to the power is it was, and if you take s is equal to 2 pi, so the value of e to the power 2 pi I will be same as e to the power 0, right? Right, class?
Yes, sir.
Yes, sir.
Yes, sir.
So you will get the same value. And if it is so, class, so therefore if you use this, then combining this information, this implies what, class? That g dash t is equal to 0. And please, class, take a note that this is for all t in closed interval 0 1, because here this t was any arbitrary t, and this implies that, class, g is constant, right, on this. And, class, now I have nothing to say. The rest of I have already explained you, and it's done. So once we have shown that g is constant, so once we have shown that g is constant, how the things will happen, that I have already explained you here, right, class? Is this okay, class?
Yes, sir.
Yes,
Fine,
sir.
good enough. So now let's take the next result, or the most important result of this section, this one. If you recall, when I started this section, I pointed it out that what we are going to do in this section. And the very first point, the most important one, was, although the Cauchy integral formula which we have done uh, yesterday and today, we have completed it, that is also important. But the very first point was this, that for an analytic function we can write a power series. So now we are going to do this. So let's start with this result. A beautiful result. We shall be writing down its proof as well. And in that proof, class, we will make use of Cauchy integral formula. So, class, you can see that how the things are developed or built up systematically one after another. We did one result, then we made use of that in the next one, then we calculated that integral, then we made use of that in Cauchy integral formula. Now we have learned Cauchy integral formula, we are going to make use of it in the next theorem. Okay, see. So next we have this theorem. So this theorem says that let f defined on this open ball. Of course, this is understood, class, that R is positive. Needless to say, this is understood. Into C. Suppose this is analytic. Class. Very simple. Only this is given. then the result says that class that for all z in this ball, for fz, for all z in this ball, we can write a power series representation, and we can write fz is equal to an z minus e to the power n is going from 0 to infinity. We can write this power series representation. Number one. Number two, the coefficients in, I call it 1, let us say, in 1 are given as ans will be given as this. These coefficients are given as this. And lastly, the radius of convergence of 1, the series in 1 is greater than equal to r. The radius of convergence of the series in 1 will be greater than equal to r. It means the minimum possible value for the radius of convergence of this series in 1 will be r, which are this r. Okay, class. So let's start with the proof. So class, I shall be doing the proof in 4 steps. You will really appreciate that how nice the proof. Okay, class. Okay. Now class, also write down this path. Let this be defined as gamma t is equal to a plus r eit. And you can denote these gamma t's by w. So class, that is what I am saying is the following. That is, what is the trace of gamma? It means the trace of gamma is the collection of all those w such that mod of w minus a is equal to r. Is this okay, class? This will be the trace of gamma, right? Is this okay?
Yes, sir.
It is nothing but this circle, class. Center A, of course, we are somewhere in complex plane. We are somewhere in the complex plane. And in fact, you can say that this is W plane. And this is radius R. And where are W's? W's are the points which are exactly on it. These are W, because here we are having equality. Is this okay, class? And this is nothing but the trace of gamma. You know all this now. Basically, gamma is doing what, class? I need not write it again and again. Gamma is taking this onto this circle. Is this okay, class? The anti-clockwise direction. Is this okay, class?
Yes, sir.
Fine, good enough. So, class, for W in the trace of gamma, it means those W's which are on the circle, and for those Z's which are inside it, it means where is Z, class? Z is here, because the distance of Z from A is strictly less than R. This we show that we show the following. Three things, or we do the following three steps. We do the following three steps. So we show, you can say, or we do the following three steps. So class, what is step number one? No. Step one. Claim sorry. Step one is writing 1 upon W minus Z. Now class, there should be no confusion that W's are on this circle and Z is inside it. Is this clear, class?
Yes, sir.
Yes, sir.
So I am
Yes,
saying
sir.
I am saying so repeatedly, it means that Z is different from W. Is this okay, class? So that 1 upon W minus Z will make sense. Good enough. So the step one is writing 1 upon W minus Z as summation n is going from 0 to infinity Z minus A to the power n divided by W minus A to the power n plus 1. Let me call it 2. So first of all, class, I shall be writing this expression like this. So let's start. So I start with this expression. This is equal to, class, simple manipulation. I think it's obvious. This is equal to 1 upon, take W minus A common, 1 minus W minus A, sorry, Z minus A by W minus A, right? And this is further equal to 1 upon W minus A, and I can write it like this, Z minus A upon W minus A and its power minus 1. Is this okay, class?
Yes, sir.
Right? And class, take a note that from this figure, this is very much clear that from this figure it is very much clear that what is the relationship between distance between Z and A and distance between W and A, class? It is this, right?
Yes, sir.
So class, this implies that modulus of Z minus A divided by W minus A is less than 1. So this is minus 1, sorry. So class, so now you know that if you have an expression of the type 1 minus Z to the power minus 1, and this class, this mod Z is less than 1, you know that you can write series expansion for this, and you know that class this is equal to 1 plus Z square plus dot dot dot. Yes or no, class?
Yes, sir.
All of you know this. This you have done at your undergraduate level. Yes or no, class? So here my Z is now this. You can see its modulus is less than 1. Is this okay, class?
Yes, sir.
So class, I would be further able to write it like this: 1 upon W minus A, and class, this will be nothing but 1 plus, and my Z is what, class? Z minus A upon
By
W.
W minus A.
Very easy. Z minus A uh, upon W minus A ka square, and likewise. Is this clear, class? Is this clear, class?
Yes, sir.
That is, now it means, class, now I can write this is equal to 1 upon W minus A, and class, I can write it like this: Z minus E to the power n divided by W minus E to the power n, and n is going from 0 to infinity. ठीक लिखा, class? जस्ट उसको सम की फॉर्म में लिख दिया है ना, मतलब शॉर्ट फॉर्म में. इज दिस ओके?
Yes, sir.
Yes, sir.
Yes, sir.
और क्लास, दिस इज इंडिपेंडेंट ऑफ एन, तो आप इसको भी अंदर ले जाइए यहाँ पर. तो अगले स्टेप में बस ये लिख देता हूँ, और W माइनस Z is equal to summation n is going from 0 to infinity Z minus A to the power n divided by W minus A to the power, it will become, class, n plus 1 power.
N plus 1.
ठीक है? तो क्लास, we have established number 2. So step 1 is done. Now step 2. Step 2, class. Class, I will show you. Step 2 is claim that this series so basically, class, I am preparing the proof of our theorem in parts. So first of all, I am preparing these parts, and then I will assemble all these to get the final product. Claim that this series is uniformly convergent. Class, please don't forget, I need to not write it again and again. I have already explained it to you that we are doing all this for what? For this. Is this okay, class? So I did not mention it again and again that what is W, what is Z, where it is uniformly convergent, right? We are doing with this setting, right? Is this okay, class? Okay. Now, So class, for that we shall be using Vrasta SAM test. So class, I am writing that for you. So we shall be making use of Vrasta M test class, which is given, which is actually section 6.2 at page 29 of your book JB Conway. So it says that let un from x is just a non-empty set. So uns are functions from x into c be a function such that, of course class, here these n's are varying, they are in capital N, right? So each one of the uns, un, u1, u2, I am saying that be a function such that mod of unx is less than equal to mn for all x in capital X. So it means corresponding to this index n, we are getting a constant m. It means you take u1, for that you will have a different number, capital M1. It means upper bound kind of number, right? You take u2 for the second function, you will have different number, and likewise. And suppose that the constants mn's satisfy this condition. It means these constants form a convergent series. Class, then Vrasta SAM test says that this sequence of functions, uns are functions, then this sequence of functions is uniformly convergent. So I shall be making use of this result. Okay class? Okay class?
Yes, sir.
So let us start now. So class, for us, let us say these are our u and w's, right? They are depending upon n, and w is variable. Class, take a note, w is moving on the circumference of that circle. Z is any point chosen once and then it becomes fixed inside that. Take a note, Z aapne once you choose Z, then it becomes fixed for the whole discussion, and w is free to move on the trace of gamma. So that's why I am writing it as a function of w. So what I am saying is that uns, they are the functions from the trace of gamma into C. Is this okay class? Is this okay class?
Yes, sir.
Yes, sir.
Good enough. So let's start with this. Now, modulus of f w z minus e to the power n divided by w minus e to the power n plus 1. So as I told you just now, these are nothing but our un w's, right? Now class, this is less than equal to okay class, before I do this, I will have to do a little more exercise. No problem. I take it down further down. Let's have a look at f first. Now class, we are given the following. F is analytic on this. We are given this class. Is this okay, class?
Yes, sir.
Yes.
Yes, sir.
This implies that F is analytic on BAR, because class, if you remember, it is contained in it, right class?
Yes, sir.
Yes, sir.
Yes, sir.
And class, because this is closure of an open ball, so class, this set is nothing but closed and bounded. You know that closure of a set is always closed, and moreover, because R is finite, so it is bounded as well. Every open ball by definition is bounded, class, always remember, because R is always finite. So this is closed and bounded in C. So it means class. Okay. I will be making use of it. Just a minute. Sorry. No, it's okay. The logic was correct, but it is to be used in the next step. And class, you know that analytic means differentiability in a stronger sense. Analytic function is continuous always. Right, class?
Yes,
Yes, sir.
So it is continuous on the ball, this. And now I am going to use that fact. So class, basically, this is a compact set. This is a being closed and bounded. Compact set in C. Right, class?
Yes, sir.
Yes, sir.
In class, every continuous function defined on a compact set is
Uniform.
uniformly continuous.
Yeah,
is
uniform.
bounded.
Bounded, yes, sir.
Yeah, is bounded. Yeah, of course, uniformly continuous also, but this time I am going to use its boundedness. Last time we used its uniform continuity. So it means F is bounded on it. Right, class?
Yes,
Yes,
sir.
sir.
And if it is bounded on it, then this implies there must be some constant m bigger than 0 such that f w this is less than equal to m for all w such that w minus a is equal to r. Agar bounded, if it is bounded, then on each of the points of the trace, we will have this. Is this okay, class? Because certainly this is containing the trace, na? This contains trace. Right, class?
Yes,
Yes,
sir.
yes,
Because if you remember, trace is nothing but the circumference only, and it is the closure of that, so it will automatically contain the trace. Is this okay? Is this okay?
Yes, sir. Yes,
It
sir.
contains the trace, so be careful. Okay, good enough. Now, okay, so I have numbered up to 2. So let me number it as 3. So therefore, now I start with this task. So therefore, class, this is less than equal to, I mean, if you want, class, just a minute. Sorry. So class, to start with, this is equal to out of this divided by, I can write it separately, and I can write it like this. Is this okay? The same expression is this okay?
yes, sir.
Good enough. Now class, take a note. This is less than equal to mod of fw is less than m. I have used 3. Is this okay?
Yes, sir.
Yes,
Now,
sir.
right. Now W, if W is on the trace, then mod of W minus A is R. Is this okay?
Yes, sir.
Yes, sir.
Right. And also take a note that mod of Z minus A upon W minus A, if you recall, it was less than 1. Right?
Yes, sir. Yes,
So,
sir.
so let us denote it by some real number, say rho. So I am writing it as rho to the power n. So take a note that here this rho is smaller than, strictly smaller than 1. And now class, you call this complete thing, if you notice, capital M is fixed, small r is fixed, it is depending upon n. You call this number as mn. Is this okay class?
Yes.
So class, I think this is not difficult to understand for you. Clearly, this series is, if you even if you take from 0, this is finite, this is convergent, because you can see class the common ratio will come out to be rho, and which is less than 1. Am I right class?
Yes, sir.
Yes, sir.
Is this okay class?
Yes, sir.
And now I think it's not difficult for you to understand that we can straightforward apply Brastas M test. Is this okay class?
Yes, sir.
Yes,
Yes,
sir.
sir.
So therefore, by Brastas M test, it follows that summation n is going from 0 to infinity fw z minus e to the power n upon w minus e to the power n plus 1, that
It's uniformly convergent.
the series is uniformly convergent. Good. Let me say it number 4. Let me say it number 4. Okay. Let me say it number 4. Now, what next? Step number 3. Class now, by Cauchy's integral formula, we know that you can say we know or we have that the value of f at any point z, where z is satisfying this condition, if z is in this disk, plus you know that its value is given by 2 pi I fw dw divided by w minus z on this trace gamma. You know this? Is this okay class?
Yes, sir.
Fine, good enough. Now this is equal to class, this is equal to 1 upon 2 pi I integral over gamma f w into summation n is going from 0 to infinity z minus a to the power n divided by w minus a to the power n plus 1 dw. Class, what I have done, I have used just this step
1
1,
upon W minus Z.
right? I have used this, right class? So I have used step 1. So from step 1. Is this okay, class? Is this okay?
Yes, sir.
Yes.
Now, class, this is equal to 1 upon 2 pi I, this summation, n is going from 0 to infinity. Now, class, this expression does not contain n. This is independent of index n, so I can take it inside the sum. So I have this. Is this okay, class? And now, class, in step number 2, I have shown you that this series is uniformly convergent. Right, class?
Yes, sir.
So, class, what I can do now? What I can do now? Someone of you please tell me.
So less than epsilon.
Oh, no, no.
So you can change the
Sir, ये
integral and
इंटीग्रल
sum.
के बाद
Yes, we can interchange the infinite sum and the integral. रीमान इंटीग्रेशन में पढ़ा होगा आपने, ठीक है?
Yes.
So let's do that. Using step 2. Okay, class. Good enough. Very nice. Now, class, this is equal to 1 upon 2 pi I. And what I do, class, I write it like this. Summation n is going from 0 to infinity 1 upon 2 pi I. See how I am writing it? F W divided by W minus a to the power n plus 1 dW and Z minus a to the power n. Is this okay, class? I can do
yes,
this.
sir.
Yeah, because here you are doing everything with respect to W only. So I have taken all that what was depending on Z outside it. And then, class, this is equal to summation n is going from 0 to infinity a n Z minus a to the power n, where a n's are what? I have said all this as a n. And you see, class, these ANs are, the notable point is that, class, these ANs are coming out to be independent of Z.
Z.
क्योंकि class, because class, you will be choosing Z. I mean, any one of you can take any Z inside that. So if it depends on that, then certainly it will be different. I mean, you will be getting different coefficients in this series. But interestingly, it is coming out to be independent of Z, and it must be actually. So class, let me say it is step number 5. So class, that is, I have shown you one thing. That is, at least we have shown one thing, that we have been able to write Fz is a power series expansion, right, class? That is, Fz is equal to, we have been able to, I can call it 6. That is Fz. Okay, there is no need to give this one a number. I can simply give this as number 5. So n is going from 0 to infinity. Where and here class, this is for this is for uh, this is for all those jets which satisfy this condition. Take a note. And fz is equal to this, where the coefficients ans are given by 5. So we have been able to do at least this much. Now class, take a note that the choice of, since, so I mean, one thing here is automatically clear. So clearly the series an z minus a to the power n and going from 0 to infinity is convergent for all z such that z is satisfying this condition. Because class, we are seeing that the value of this infinite sum can be given with the help of the value of the function at that point, na? Whatever z you take, it means the sum of this series is coming out to be finite. Is this okay, class? Because
Yes.
if you remember, our function is going from somewhere to whatever that somewhere was into c. It is not going to c infinity. Is this okay, class? It is going to c. It means the values of fz are going to be finite. Is this okay, class?
Yes, sir.
Yes. So I can say that the series is convergent for all z satisfying this condition. Now, just class, I am going to wind up the proof. I'm almost done. Very nice proof. Just a minute, class. I'm just going to finish the proof. So, class, now since so class, what we were to show, yeah, coefficients are given by this and radius of convergence is greater than equal to r. Yeah, so we have shown the first thing. Okay, now since r is smaller than capital R, this r, I am talking of this small r now, this was arbitrary. Now class, this choice of small r was also arbitrary. I took any number smaller than capital R, right, class? Therefore, we can say that summation n infinity an z minus e to the power n fz is equal to this for all z such that z minus a is less than r. So I can extend this small r up to capital R. I can take any value of small r. So I am taking it up to r. It means what, class? It means this series, class, is converging for all those z which is satisfying this condition. Is this okay, class?
Yes, sir.
But class, take a note. I am not saying that this r is its radius of convergence. No. I am saying only that this series is convergent for all those z which are satisfying this condition. So at least at the minimum, this series is convergent for those z which are satisfying this condition. It may be possible that there may be some z's even beyond this condition. Now what is this condition, class? This condition means class, this condition means class, all those jets which are inside it, at least for all such jets, we are getting the convergence of this series. But it does not mean, it means class that at the most, at the minimum, its radius of convergence will be at the minimum r, because every point inside, for every point inside this, the series is coming out to be convergent. Of course, it is possible that there may be some points outside it, so that for those points also it comes out to be convergent. Right, class?
Yes, sir.
सर एक बार लास्ट लाइन रिपीट कर दो, वॉइस ब्रेक हो गई थी.
I repeat. Please take a note. I am nowhere saying that this capital R is radius of convergence of this series. What I am saying is that from our observation, we are seeing that this series is coming out to be convergent for all those jets which satisfy this condition. This is what we are getting. So it means, if I am saying so, it means the minimum possible value, that is the minimum possible value for the radius of convergence of the series, let me say it, the above series, okay, of the above series must be R. At least R should be, कम से कम R तो रेडियस ऑफ कन्वर्जेंस होगा ही होगा, क्योंकि इतने पोर्शन में तो हर पॉइंट पे कन्वर्जेंस आ ही रही है ना. रेडियस ऑफ कन्वर्जेंस अगर होगा तो इतना तो होना ही होना चाहिए, क्योंकि इसके अंदर किसी पॉइंट पे डिस्टर्बेंस क्रिएट नहीं हो रही है. नो क्लास?
Yes, sir.
So now I am claiming for radius of convergence. It means, in other words, when I am saying minimum, तो R तो होना ही चाहिए. It means it should be either R or bigger than R. Radius of convergence R से बड़ा होगा या R होगा. अगर मिनिमम इतना होना चाहिए तो उससे बड़ा ही होगा या उसके बराबर होगा, क्योंकि इससे इसके अंदर अंदर कोई प्रॉब्लम नहीं क्रिएट हो रही है. So in other words, the radius of convergence, please don't confuse, I am not saying this capital R to be radius of convergence. I have nowhere said during the proof of this theorem that this R is radius of convergence. I am trying to have an idea about the value of the radius of convergence. So in other words, the radius of convergence of the series, this is understood now, we are talking of which series, must be greater than equal to R. It means, class, you see, it is something like this, class. Suppose we say that if you want to get admission to M.Sc mathematics, you should have minimum 80% marks or minimum 8 CGPA at your undergraduate level. So it means what? That it means you should have marks greater than equal to 8 CGPA. Is this okay, class? As simple as that. Okay. So class, if you notice, I have made the third claim as well. I have made this claim as well. So I have made this claim, I have made this claim, and now we are left only with the second claim, and it will not take me more than 2 minutes. Finally, we have class, we have, since we have, what was fz class finally? It was an z minus e to the power n is going from 0 to infinity. And class, this is power series, and I have already told you that a power series is infinitely differentiable. Yes or no, class? Do you remember that? Within its radius of convergence.
Yes, sir.
Right?
Yes, sir. Yes, sir.
So this implies that I can talk of its first time derivative. What will be, class? F dash z? Can someone of you tell me? I mean, this is very easy. Sorry. For example, you just write it in the elaborated form. We have this is equal to, or I write it like this. You write it in the simple form: a0 plus a1 z minus a2 z minus a square plus a3 z minus a cube, and like this. Is this okay, class? Now,
Yes, sir.
using the fact that a power series is infinitely differentiable, and if class you remember, whenever we differentiate a power series, the radius of convergence of the new series also comes out to be the same, right, class?
Yes, sir.
Yes,
Yeah.
sir.
Yeah. Okay, now using the fact that a power series is infinitely differentiable uh, within its domain of convergence, oh sorry, radius of convergence I must say. Actually, I'm saying domain of convergence means the portion where it is converging. Domain means that. Don't confuse it with the open and connected side. Domain means simply here the domain terminology. It's domain of convergence. We have class C. What will be f dash z?
A1 plus 2A2 Z minus A.
Yeah. Just a minute. It will be a1 plus 2a2 z minus a plus 3a3 z.
Z minus A square.
Is this okay, class? Therefore, the value of f dash at a is how much? a1. Is this okay?
Yes, sir.
Yes, sir.
Now repeat the process.
A1.
Right? Again, repeat the process. F double dash z. This time it will be z minus a square. I hope you can imagine this. And what will be the value of f double dash at a? It will be 2a2.
282.
Right? Likewise, class, you just go on doing this. You do this exercise. Similarly, I can write. Similarly, you will see that fn at a will come out to be n into n minus 1, 2 into 1. You can see that trail here, class. Can you see this trail?
Yes, sir.
And into an. And this is nothing but class n factorial. So that is, it means what, class? That is, ans are coming out to be of the type, the value of fn at a divided by n factorial. And this is the last claim. Is this okay, class?
Yes, sir.
Yes, sir.
Very easy to understand. So the coefficients are of this type. It means the coefficients of this power series you can determine with the help of the function. Because class, you are given a function, you want to write power series for that function. So to write the power series for that function, what do you need? You need only this. And now this you can determine with the help of the function itself. So you can easily write. Is this okay, class? If you recall,
Yes, sir.
this is how you used to write the power series expansion for sin x, cos x, and now we can write the power series expansion for sin z, cos z, exactly the same way. Is this okay, class?
Yes, sir.
So let's stop over here. So this was very important.
Excuse me, sir.
Yes.
सर एक बार वो ऊपर जहाँ पे इस फंक्शन को कंटिन्यूअस बताया था वो एक बार एक्सप्लेन कर दो जहाँ हमने पहले फाइनाइट बोला था और फिर कंटिन्यूअस
Here.
नहीं नीचे जब लास्ट स्टेप में वी हैव रिटन दैट सिंस दिस सीरीज an z minus a की पावर n is continuous.
No, I said it is infinitely differentiable. Because this series
नहीं
is...
that we have said now na this
Yes.
series is continuous.
No, where I wrote this, and calling series continuous means, I mean, what is that? I mean, that terminology itself makes no sense. Calling a series continuous means what?
You wrote it above.
Where I have written
Below point nine. Below point number 5.
below point number 5. Where I have written that series is continuous. Tell me. Nowhere. Because calling a series continuous,
अच्छा, sorry. हाँ.
I mean, I don't know what does that mean.
Hmm.
Actually, when we say series is continuous, then in the sense of
हाँ, okay.
mathematics, that means that the function which is being represented by that power series is continuous. But very often at our level, at the M.Sc level, we don't use this terminology that this power series is or the given series is continuous. We don't use that terminology, right?
Okay.
हाँ,
Okay. मैंने वो गलत लिखा था. ठीक है. हाँ. Okay.
की जरूरत
Thank you.
क्या है? मैं तो ये सारा पीडीएफ बना के भेज ही दूंगा.
नहीं, वो प्रूफ के बीच में कनेक्टिविटी टूट जाती है. ऊपर वाले स्टेप में क्या होता है, इसलिए प्रूफ लिखा था.
अच्छा, कोई
इसलिए
बात
मैंने वो कंटिन्यूअस लिख दिया, तो मुझे वही डाउट था.
नहीं. तुम लोगों को अभी शाम तक ही पीडीएफ
थैंक
इसकी
यू.
भेज दूंगा, तो रिवाइज कर लेना, ठीक है?
ओके सर.
Just a minute. So let me take your attendance. The proof was so lengthy and systematic, and so many things were to be done in the proof that I know that if teacher is not well prepared for such a proof, it really becomes very difficult to complete such a proof in time. Okay, class, I have taken your attendance, and once again, uh, I repeat the message that tomorrow I will not be taking your class, and now we will be meeting on
Thank you, sir.
Tuesday. Okay, thank you, class.